So now we come back to the circuit we had in the last video, except for it says 9 volts where it used to say 5 volts for powering this. And you may notice the blue LED is brighter and the red LED is brighter. We are using 9 volts now. So a while ago I made 2 of these schematic diagrams for whatever reason. Off to the left side of the page is the 5 volt version, but otherwise I think they're exactly the same. We can go to 9 volts, you know, everything is wired for more than 9 volts except for the LEDs even. We could go up to 12 volts with the circuit right there. But we have a 1K resistor protecting the red LED instead of 220 ohms. But in any case, here's the circuitry. So the what happens is we have one push button right here. The output's either high, red LED is lit, or else the output is low, where the blue LED is lit. When the output is high, this capacitor is charging through 2 resistors. So this resistor, I figured out, was causing a problem with the last video, which I have that resistor there now. And I concluded that using a higher value resistor, such as 100K, would fix the problem, which it did. But in any case, we got a high output. That capacitor is charging. It'll get fully charged at some point. You close the switch though, pin 6 sees a higher voltage. Normally it's held to half of the supply voltage right there. But closing the switch, we get higher than 2/3 of the supply voltage, which sets the output low. And also pin 7 starts discharging. So this is where the problem comes. We have twice as much resistance charging versus discharging. So it discharges very easily. If you hold the switch down for, it was like less than a second, then the capacitor discharged a little too much, gave us a low input to 2, and that set the output high, and then 7 stopped discharging, the capacitor started charging again. I think at that point we could keep holding it and the capacitor would not be able to charge above 2/3, I believe. At least it would take a really long time, longer than what I tested in that video, to, you know, raise the voltage, because we're trying to hold halfway there. So with that charging, I don't think it was able to overcome the voltage divider that we have over here. So hopefully that makes sense. These 2 resistors here, this is not connected, that's jumping over. They're trying to hold half of the supply voltage there. But when you close the switch, the capacitor will instantly either bring it above or below 2/3 or 1/3 supply voltage if it is beyond that point. But then hopefully they will be able to pull it into a middle ground region, the hysteresis region, where even if you hold the button down, it will not be able to influence the output anymore. So yeah, we'll go over here. So here we have the high output. You can see if I hold the button down, we got that blue flash, and maybe I think that was switch bounce. I'm going to keep holding it down. See, yeah, it won't go back to blue, but if I hold it down, it will quickly go from low to high. So if I just press the button quick enough, there we go. It will stay low, you know, as long as I release the switch in time. But we didn't have much time to work with there. So as I said earlier in this video, that I believe with a 100K resistor, and I did test this before I made the video, of course. So I'm not going to be surprised that this works. That was false signals. So there's all kinds of ways for me to falsely trigger this. There we go. Now we're in the right spot. You should cut the power, turn off the power supply before you make modifications. Okay, let me make sure I did not wire that right. That was not supposed to go there. There we go. It's supposed to go up to pin 7. So I did wire that wrong. That's why it didn't work. Now, this should go low. And we have to wait longer now. So I think it might be up to 5 seconds. Maybe that's how I came up with the 5 seconds. Maybe I wrote the wrong resistor value down by accident. Maybe when I was making this, I intended to make that 100K, but I wrote the wrong one. But there you can see, we can flip them back and forth. let's get it. Okay, looks like we got to wait probably a little bit longer right there. And now we got the output high. So I'm going to let the capacitor, it would be charging right now. And so we're going to hopefully get it to where it is fully charged there. And so now I'm going to press the button. And before, if I was holding the button down, it flipped right back to high. I had to do a quick press release to avoid it from going high. So there we go. I think we got a pretty good working circuit right now with this 100K. There we go. We got back to high. And I don't know, maybe that's like 3 seconds there. We can go low. Let's try about 2 seconds. So yeah, at some point we'll be going a little too fast. But yeah, it looks like even that speed. Okay, just a little, got a little too excited there. But yeah, nice nice calm pace there. We can go back and forth, and we can hold the button down. Hopefully forever. Maybe at some point the capacitor will be able to charge up to 2/3 or down to 1/3, depending on which way you're going. But looks like we pretty much avoided that issue altogether, maybe, but definitely good enough to make this a practical circuit. So, in any case, I don't think I'm gonna especially not reprint out this circuit. It did work with the 10K. Maybe I will at some point. But for now, that's it. Hope you enjoyed this extra video. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.